Assalamu alaikum. The progress report for 8th of September 2017. So here I will be discussing about the continuation of my literature reading for nitrogen-doped graphene. In 2016, one paper discussed about more of graphene oxide dispersed in acid solution, which is hydrochloric acid, and sonicated. So this particular paper and these papers that I've been doing is more focused on the use of aniline with polymer. So this paper uses APS and dissolve into the HCl solution before we kept in ice bath. The final product is washed with dilute deionized water. And the next paper by Lin 2016 have a particularly similar method by using the graphene oxide dispersed in acid before sonicating, and also using the monomer of aniline and not dissolved but into the concentrated HCl before using the APS or ammonium persulfate and to obtain the polyaniline graphene oxide. So in order to remove the excess monomer, you have to paralyze it at a high temperature between 700 and 900 degrees Celsius for 2 hours under a nitrogen flow. The next paper from Haydari 2016 uses a general method of using graphene oxide dispersed in a concentrated hydrochloric acid solution, and the monomer of aniline was added dropwise. This particular paper discusses in detail how the nitrogen-doped graphene is made using polyaniline. So this paper is really may be useful for me as a future reference. And this particular paper from 2014, Lin uses interfacial polymerization, which is different from the last two papers that I just discussed, and it still uses aniline, which is the polymer that I will be using for my research. But instead of dissolving it in acid, it dissolves in this. I have to look this up. Well, it's a different method than the last two papers, and the graphene oxide and the iron chloride is dispersed in the acid and sonicated for 2 hours, therefore obtaining the polyaniline graphene oxide suspension before it is centrifuged for 3 minutes and washed, rinsed with pure water, and vacuum dried at 40 degrees for 48 hours. So the last one, this method uses potassium hydroxide, which is interesting because none of them uses this kind of this material, and at the end of this product, it will obtain the nitrogen-doped graphene, which is pretty interesting for this method. So that will conclude the progress report for this session.